Hello. Hopefully everyone can hear me. All right. So I just posted the grades. And I think there are probably not too many surprises. Everybody is still in pretty good range for good resolution for the semester, the summer semester. Feeling pretty good about things. Hopefully you should all feel pretty good about things as well. Let me just chalk up. Okay, click one more button and click recording. And let's see, my Twitch. I guess my Twitch stuff isn't quite right. Oh, anyway, the title on Twitch isn't quite right. Anyway, so I wanted to talk today about what we consider to be sort of best practices, class management, patterns, programming patterns, and you probably have heard about this stuff hopefully in your other classes. I forget if it's fundamentals of computing or intro to algorithms or which of your classes, but general software development and design. Sort of we get into these practices and this sort of like what we consider sort of our go-to methods of doing things. If we have a certain solution, we have like sort of a bag of tricks, a quiver of arrows, kind of our toolkit of things that we're going to do. And so after looking at, we get the first 3 projects behind us and looking at everybody's code, some of these things are going to be review. Sometimes I use this lecture earlier on in the semester, but this time, figured we'll kind of cover things. And some of it is talking about some of the things that I've seen throughout the semester in terms of habits that people have gotten into. One thing I wanted to mention in general, I think I haven't seen in the projects quite that much embrace of a couple of things. I haven't seen a lot of use of events yet. So hopefully there's some use of events in the final project. That's something I'm going to be looking for. Use of inheritance. Didn't see an awful lot of that in the projects up to date, but hopefully we'll see those in the final ones. So if you're looking to knock my socks off, as they say, those are some things. And in general, the use of coroutines, I think it's worth considering. I mean, I've seen some people did, some basic use of them, and coroutines are definitely more than just, spawning another function or just, using it as sort of a simultaneous subroutine to call or a certain amount of parallelism. I think you should really be thinking those as a design practice of when you need to have something that you don't want to have inefficiently done in something like an update routine. You got to remember in your update routine in Unity, for example, in your main loop of any engine that you're using, you don't necessarily want to be polling everything every frame, especially if you have some idea as to when those things are going to happen. If they're going to happen at a constant interval, or they're going to happen in basically reaction to something, the user clicks on something, or there's a collision that happens, or there's some, number of things that happen, or, an enemy needs to scream when the player picks up a power-up or opens a door or something like that. It shouldn't be a matter of sort of polling all the time. Things like events, things like coroutines, and even anything we're going to do for decoupling of code and also avoiding polling. Those are some key things. And those are useful techniques no matter what type of programming you're doing. So especially if you're doing, any kind of large scale, not game programming, but large scale performance oriented things. If you're going through millions of records in a database, or you're going through millions of transactions, or even online in a web server or web service or something, where you're trying to really, maximize your throughput, efficiency is going to come into play. So what we're doing now in things like, with these basic concepts, in a simple game and a simple, certainly 2D game with limited number of characters and limited number of polygons, it's not quite so critical, but you really want to build on those kind of skills and those things that you get good at. All right, so let's dive into the lecture material. Again, this shouldn't be necessarily a lot of new stuff, but hopefully maybe a little bit more refinement, and you can think about these as you're doing stuff for your final project, your last project. All right, so class management and patterns. So a lot of this is related to class management because after all, C#, C++, most of your object-oriented, your high-end, higher-level languages are based around this unit of objects or classes or structures, that sort of thing, right? So let's dive in based on that. Whoops, and that is the wrong, there we go, wrong thing to be pressing a key on. Now, first off, a review of the 6 elements of a Unity game, or really of any game. So we have the game objects, the things in the game. We have the functions or methods, the rules. We have the properties, which is the data you have. You have components, which are things that are basically components sit on game objects, right? So components have properties and functions, and they are on game objects. And then you have events, the conditions that are when things occur. And the thing I left off number 6, and I'm interested to see if anyone remembers what is, or will know, what is that 6th thing that should be part or should be considered as part of every Unity game, if not every game. It's kind of an important thing to always be considering that's going to be causing the events or causing you to make certain decisions about how things are presented and so on and so on. And let's see, somebody's typing. What is the other part of the game? Very good. Exactly. Boy, I can't put one over on you guys. This is fantastic. Okay, yes, the player. So what the player is going to do, the player is the one that's going to be interacting with all of these things. A lot of time, the player is going to be causing the events, but the player is also going to be consuming all of the things that you put on the screen and reacting to them and so on, right? So you have to kind of consider the player's experience and what the player is going to be feeding back. The player is part of this programming loop that you have, right? You cause something to happen that hopefully is going to cause the player to do something that is then going to cause your program to do something. So there's this constant feedback loop. So the player is very much part of, right? All right. So going back, sorry, clicking on some other screens here. So class management goals. And mostly we're going to talk really about the class side, the computer side. We're not going to talk about the player so much. Your other courses like game design and storytelling and so on, we're going to talk a little bit more in those about the player experience. But for here, we'll talk about mostly the components on the machine side. All right. So remember, when you're designing your classes, right, part of the idea behind designing classes is that it should be allowing for easy adjustment of values for balance in your game. Remember, if you can have that one knob, we talked about, knobs for interpolation or blending values or setting controls. If you can control your gameplay or certain aspects of it with a knob to kind of turn up the balance, are enemies spawning fast enough? Are they moving fast enough? Are they, how does the player move, the speed and so on. So if you have these notion of, exposing through your design of classes and so on, so there shouldn't be like a million things that need to be changed in order to affect a change in the game. It's nice to have, higher level control so that you can eventually, as your game comes closer and closer to being distributed or to finished, I should say, that your tweaks and adjustments don't require you changing tons and tons of code. It should be more about, higher level modifications or adjustments for balance. Right? So if you design your classes well and their APIs, their programming interfaces, their relationships well, you can get that. Right? As you're designing your classes, you want to avoid coupling of different game objects to one another. What does that mean? Well, that's about when you're explicitly touching things inside of other components, or you're relying on them specifically existing in certain ways or having certain functionality. If you're calling a specific function as opposed to reacting to an event, for example, right? You want to use getters and setters. You want to use, there's this notion of fields versus properties, where you have a get and set routine. If there is something that other classes or other objects need to access within one of your classes, you should think about having these explicit interfaces like get, set, fields and properties, doing them the right way to avoid coupling, right? Events also allow you to do that as well, right? Class management is also about grouping similar functionality together in one logical spot. It's about logic throughout your game. Things make sense where they are. If you need to find something, it's grouped in, it's, if you have player motion, it's on the player object, it's in the player controller, right? So that's where all the player control happens. That's not necessarily where the scoring happens, right? The player controller may interact with the scoring, but maybe the scoring should be in its own object, right? Sometimes, you start off, if you have a fairly simple system, then that might not make as much sense to kind of break things apart into tiny, tiny pieces. But you should be thinking in that way, because as games become more complex, that's going to increase the potential for this kind of spaghetti of things. So be careful with that, right? You want to limit repetitive code from across different scripts, right? So in this case, this is more a use of, you may have classes that are libraries, like the math functions, the vector functions, the scene manager, the UI manager, all these sorts of things, so that you don't have repetitive code that's, you're not calculating the dot product a million times explicitly in code, or every object doesn't have its own way of, determining what the dot product is, right? So by having classes and managing them well, you can avoid this repetitive code, and repetitive code is usually fragile code, right? Because you have to remember, if it's repetitive, you have to change something in every spot that it is repeated in. So that's something you want to avoid. So that's why we want to carefully craft our classes and manage them well, right? And to do that, we want to, of course, make our scripts reusable and extendable or extensible for different situations. So it's writing things in a way that, again, it's not like, well, okay, acceleration isn't only something that this particular object is, or even like firing a weapon. It may be that the same weapons work no matter whether it's the player or the enemy, right? There should just be a fire function, and the player calls the fire function as a reaction to user input, perhaps, and the fire button or the fire action on the enemy or an NPC might be in reaction to some type of sort of AI or some type of event or some type of sort of time. But functionally, it may very well be that the fire function itself is the same, right? We don't know how exactly it pointed or how it aimed or something like that. But the end result, that, a starburst of bullets pop out, that might be very much the same, right? So if you can do that, great, all the better. All right, so let's talk about these things. Balance, easily editing values. So tip number 1, make everything that you can into a variable rather than hard coding it as a set value. So there were still, I see some examples, and I even do it myself. Sometimes when you're prototyping, it's easy to throw in a variable, 5, 3, speed. The thing I use 3 as a default speed a lot of times. 3 meters per second is a reasonable speed, but it'd be better, of course, to have speed that you refer to, so that you can then tweak it from outside of the code. And if you commonly have a speed thing, that's the normal way among all your functions or among your design patterns to say, okay, I always have a property or a field called speed. Well, then when you're trying to tune a particular object, its behavior, just go for speed. You know how they all work, because you have worked that out as a kind of a common practice, right? For example, define speed rather than hard coding it as 10, right? And another tip, make sure anything you might want to adjust, make it accessible in the editor, whether it is as a private serializable field or whether it be specifically as just a public. Public is optional as well. You can do public, but it's more often better form to do things like private and serializable. This way you can access them in the editor, but you don't necessarily access them across code, right? You don't have potential conflicts. You can make it public or use serialized field if it's private, right? Also remember, you can edit these values while the game is running, of course, right? The cool thing during development, you can change them in the editor or you can change them in code, right? If you change them in the editor, they will kind of snap back to wherever, right? The editor, any change in the editor is temporary, but it is kind of cool that you can kind of interactively, while the game is playing, tune your game potentially. All right. Define variables with a set value as a constant at the top, okay? So constants can never be changed during the game, but it gives you an easy way to change it during setup if needed and make sure it changes everywhere. So even if you are referring to, if you have some kind of hard-coded number that you do want to have hard-coded, use a constant value, use the constant declarator when you're defining a variable, perhaps. So this way, it's something that, it's set once, you have some common place to do it. You're 52. There's 52 cards in our deck. The code can't change that, but we can refer to deck size as opposed to referring to the number 52, right? That's a good practice. All right. So mentioned pattern number 1, creating tiny reusable scripts to manage basic behaviors. So for example, these scripts should have common following characteristics. They should do one thing or a set of related things. Think of a math library. They can be attached to different objects and still function correctly, right? They don't rely on other components or anything specific to an object. So examples of the situation where it could be useful, imagine you have a script that you attach to an object that makes it persist across scenes. A bunch of people I have seen use that to have background music kind of persist across. I've done that. I have my don't destroy on load, kind of a common class that I can then just call in. And I can go back to any particular project. You could even save those as you get into larger projects. You may very well have libraries that move across from project to project that you kind of just come back to, right? It just becomes a library for you. So you can use that to persist things across scenes. You can also use statics to have things persist across scenes as well. All right. Where did I go? Lost my train of thought here. Okay, script that controls changing the scene to a given value, right? Scene management, simple stuff like that. A script that makes text automatically blink, like a blink property, or even maybe it's not even text. Maybe it's just anything that messes with a renderer in a specific way. One example in some of my code is I would create a thing called a fade routine or a glow routine, and just have a class that I can attach to any object or the damage. There was a damage behavior, a damage component that I use across all the objects or almost all the objects in my CoinGen game, where I would just attach that object or attach that component to the object and then set a number of hit points, and then that would manage the object, and it would say, well, okay, just keep track. Every time you call that, you tell it how much damage is done to it. And the moment enough damage is done to it, it would then destroy the object. So it didn't matter what object it was. Everything was damageable in that case, right? So, for example, also a script that deactivates an object or its parent when a button is clicked, right? So you deactivate something, sort of like the damageable or destructible, but in this case, just use a calmer, gentler deactivation as opposed to destruction or destroy, right? Now, this is one I haven't introduced before, but it's a useful thing. And this is sort of in the opposite direction a little bit. Sometimes you may have a script that assumes that there is some sort of other component available, okay? And in some of our things, we've seen it where we would say, okay, get component. Every time you call get component rigid body, right? So if in your hero, you say get component rigid body, and then you refer to things that are referring to things about that. What you can do is you can actually put something in your hero controller to say, all right, we're going to use this attribute at the top of the class to ensure that that component will always be attached to the same game object. So if you use that particular class as a component on a game object that doesn't already have the other component that it needs, so your hero, say you tried to reuse your hero controller and you dragged it to another object and that object did not have a rigid body, this would give you an error, right? So you can require component type, right? Such as this. I should have used the rigid body one. But anyway, you'll get things that'll error out if it does not have that component, which is kind of cool. So here's some simple examples, things where you have your don't destroy on load a new scene. These are all small bits of code, but you can kind of use them. Here's another one, invoke repeating if you want to blink at a certain rate. All right, so all this is doing is saying, okay, when you wake up, you invoke repeating with that of calling this routine at this rate, right? So maybe you want text to blink all the time. So this can be attached to that. Any blinking text you need, just attach this to it, right? And then in the editor, you can set that to whatever number you need to. Right? If you needed to disable an object according to a button click, here's that example. Right? So on awake, it would make sure that the components necessary were hooked up, and then it would know to add listeners to disable its parent or disable itself, depending on who is clicked and what state is going on. Right? All right. So if you haven't already done this, think about this. In any of your previous games or any of your previous projects, is there any code that you might want to use in your final one or in the future, right? Think about reusing one of your scripts, and how can you just use it as is, reusably across another project? If not, think about this. Maybe you do want to use this as a exercise. So create a script that can be attached to a game object to make it move in a given direction, reverse direction when it gets to the edge of the screen, right? We've needed to do that in the apple picker and so on. So create a second script that requires the first script, right? You can require other scripts, just like any other component, and then use the speed value to randomly change direction, right? So think of this going forward, about the reusability of scripts. All right, pattern 2, create managers to handle sets of related behaviors, right? We've seen game manager, you've seen hero controller, right? These are sort of higher level managers, right? A lot of times the game manager, that's why the game manager has a special cog icon that it gets when you create that script, because it's assuming that that's some sort of group of handled or related behaviors that are kind of managed by this script throughout the scene. Right? So more complex scripts that are responsible for handling a set of related behaviors so that other scripts don't have to. So you might have a score manager, scene manager, game manager, right? These are the sort of kind of nuts and bolts that need to be taken care of for the game to run, right? It's not specific to a particular object in the scene, right? That's why we have these managers. So then you can get a reference to the manager when you need it. If you find yourself having to make reference to the same things over and over again, consider them to check what the current score is and save it. And so, for example, common types of managers, the game manager, the UI manager, maybe an audio manager, because we have lots of references to audio sources that might be reacting to different sorts of things in the game. Right. And the nice thing about having external managers is that they live outside of a particular object as well. So a lot of the time you use an audio manager because you don't want a sound to get clipped, to get stopped from playing when the object that it's attached to is destroyed. Right. You have an explosion. It's tough to play the explosion sound if that audio source is on the object that gets destroyed, for example. So instead, the object that before it's actually destroyed would call the audio manager and say, play the sound for me, and then destroy itself, right? That's the nice thing about having managers for you like that. Okay, we have a question? I thought someone was typing. If you have any questions, let me know. Oh, okay. Say scene manager or even thinking about it in a standardized place like that, just to keep it from. So every single object isn't necessarily going to have to talk to the manager, only the ones that are interested in, specifically changing something, right? And maybe you do wind up creating different ways for if there's like really specialized cases where, only one particular thing, but it's normally like, imagine you have things that explode, and each one of those is going to add some amount to the score, right? So what should happen is any object could call game manager dot increase score, and it would just pass the number of points that you would earn as a result of that. Okay, my fan just started spinning up on my computer, so hopefully I don't lose. If I glitch out, that's why. I don't know what it's doing. So generally, you only want to have things that need to refer to them, but it is about, kind of that commonality function that exposes that capability by the manager or the game manager, so that everybody just refers to that one way of doing it, so that's consistent, right? It's about consistency, right? So this should be create managers to consistently handle sets of related behavior, right? To always do things the right way, so you don't forget to update something, or because your score might have a health bar above the player as well as a number on top of the screen, right? So you have to update both of those, right? So your enemy might not have a handle to the player, or so on and so on, right? So you just want to call the game manager to do that for you, right? So basic manager pattern. So here's for example, right? So here's going to be an audio manager. And so the audio manager is going to handle our audio clips here. And we might have a certain number of audio clips and a certain number of audio sources that could potentially play. So what we can do is we can say, okay, if we need to play a button effect here, we can use this sound to play a one shot using this source, right? If we need to play an attack sound, we can use the play one shot, play the attack source, and so on, right? This way, then the player doesn't really need to know specifically about what audio clip, right? Because you may later on, your designer may decide, oh, okay, you know what? We're going to use different audio, right? If they said, okay, I'm going to be using a different audio clip, or I'm going to do a combination of things, or I'm going to trigger multiple sounds or something different, right? So if you have things organized like this, where you just say, okay, call the audio manager and play the attack sound, let it know I'm attacking, right? Now, alternatively, you might have some things in here where there's some events being called back and forth. But for now, let's just assume it's a simple manager, the manager pattern, right? So that's the idea behind this. So as an exercise, make a basic manager. Think about how you're going to use that in your game. Hopefully you are using a game manager or a scene manager or score manager or an audio manager right now, but I am going to look for that sort of stuff in the final project. Definitely going to look things kind of closely. Everybody's doing really well. I'm not concerned, but I'm definitely, now's the time to make up for, the few lost points here and there sort of thing, and make sure that's in there. So structuring your code well, your objects well, will be cool this way. So think, for example, the UI manager. How many places do you normally touch the score text? Right? It'd be better to have some common way of touching the score text, especially if you have multiple enemies or things like that. Right? So think about this. Use this exercise in your game if you need to. All right. Pattern 3, create static variables, methods, or classes to access them anywhere. Statics. I haven't seen a lot of use in the projects of statics. Is everything still playing? I thought, yeah, I think so. Okay. All right. So the static is happening weird. We'll pause for just a second. Hopefully YouTube is good again. All right. Sorry about that. So pattern 3, create static variables, methods, or classes to access them from anywhere. So the static, if some property or of that class is defined to be static, it means that it can be used basically across the whole project. The moment it is part of your project, it can be used across the project or across the scene potentially. Of scriptable objects. Scriptable objects are sort of, right? A scriptable object is something that basically exists across the whole project as a class, right? So you have to be careful in them in that anything that they refer to is not already static and it doesn't already exist. Okay. Right. So it is useful when you have something that will never change across instances of an object or where there will be only one copy. Things like the score, right? It makes sense that you have a static reference to the score, right? There should only be one reference to the score. There should only be one score. The int that is the score should potentially be static. This way, everyone can just refer to it, and they are referring to the common thing. So avoid using it when you need to use non-static variables, such as saved references to objects, scripted object, or another basically class that you can refer to from C#, and it just has these commonly defined strings, right? So then anytime you knew, okay, I want to call the start scene, I should go scene name.start scene, just in case someone decided to change the name. It's not start scene, it's start scene version 2, game scene 3, right? So if you've already defined these as part of this static class, then they're there once and for all, right? That's why we like these things. They decouple us from these constants. They allow the constants to be sort of organized and put in one particular area so that they are kind of separated from our functional code, right? Singletons, I'm not going to talk too much about right now. We went into and showed some examples of singletons before. And singletons are useful. We talked about them, basically after static, because to implement them well, usually are using some instance of some static to figure out which instance should be the one and only instance. So singleton is a class or a description of any particular class that contains some globally accessible instance to itself and can be used basically to make sure that there is only one of these. And chapters of books have been written about singletons. So here's one example, yet another example of how to implement a singleton, to say, okay, the moment you awake, use this static instance up here, because there's only going to be one of these instances for this particular class. So you can say, okay, if I am awakening and instance is set to null, I can be the instance, right? This is I'm playing the musical chairs. Nobody's sitting in the chair yet, so I jump into the chair, right? Otherwise, if somebody else is already sitting in the chair, I destroy the object, right? I destroy this because it shouldn't already exist. And it's kind of interesting. This is one case where this is destroying the game object that this component is on. Sometimes you may have a class that is a singleton class that you only want to make sure only one of these classes exist. And in that case, you would just say destroy this, to destroy this particular component and not necessarily the game object it was on, right? So you could have one on multiple game objects, or you can even try to put multiple ones on the same game object, and it'll just say, oh, whoa, 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 you can only have one on here, right? So a singleton class would be something that you wanted to just make sure there's only one of that component on a game object, right? So the moment the second one tried to run, it would get rid of itself, could disable itself, something like that, right? So say you accidentally, because you wouldn't want like 2 rigid bodies, for example, on the same component, maybe, right? You've probably seen instances like that where you couldn't put a second component of the same type. And that's something you could do through the use of a singleton, referring to the class as opposed to the game object here, right? Okay. Sort of static singleton. Yeah, I should rework the slide a bit. Sorry. Removes the need to get a reference to the object to do things with it. Sort of makes it easy to maintain persistent data across scenes. That's true, because a singleton can be used with the don't destroy on load, for example. Unlike a regular static class, it can contain non-static references. Yes. So this is a singleton that unlike a regular static class. Let's see. I want to revisit this one, because you don't necessarily have to have the singleton to contain non-static references. You can always use a non-singleton with a static to have that. Let's see. Disadvantages: can have access to it using the instance keyword not directly because it's not a static class. Like a static class can only ever have one copy of it at a time. That's true. Easy to set up incorrectly or cause hard to trace bugs. That is true. If you're not careful with singletons and statics and so on, you can wind up with kind of dead ends in your code potentially. You have to be careful of that. So like I said, there have been at least chapters of books written about singletons, and some will argue that they should or shouldn't exist. And singletons aren't something that is again, it's not something that is totally unique to game programming either. The singleton pattern goes well, and a lot of these patterns go well beyond just game programming. All right. So as an exercise, go ahead somewhere, maybe your UI manager, or you have some kind of don't destroy on load using background music or something like that. Go ahead and try that using a singleton. So here's some other useful tidbits organizing your code. Enums. I'm surprised I didn't talk about enums before. Enums, enumerated values. All right. So sometimes you have things that can be one and only. It's sort of like a state. It's not a state machine, but it's something that designates a certain state. Like, for example, the day of the week, right? It can only ever be, we have some number of days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, right? I already said Sunday. I said it once. There should only be one instance. There shouldn't be two Sundays in the days of the week, right? So this is a set of days, a set of potential days, and it represents the totality of that set, okay? So you can't have a value that is outside of the set if you are referring to something according to the day, a variable that it has been specified to be a day of the week, right? So it's useful when you want to keep track of limited options, and specifically if you have, for example, a switch statement where you have some number of states. So if it's Monday, do this. If it's Tuesday, do that, right? This is the way you define it. Say public enum day of week, and then you can refer to it like any other class or any other type def or defined type. But then if you want to set the value, you have to set it according to day of the week dot and one of the values, right? So current day can only ever be one of these. And internally, it really represents them as 0, 1, 2, 3, 4, 5, 6. That's what it actually, I think it winds up being internally. But you can't refer to it that way. You have to refer to it this way. Properties or fields. But properties they combine functionality of methods and fields, allowing you to define inherent behavior for a variable. So this is about providing a specific interface to a variable, or interface to a property, or interface to a field of a class, right? So say, for instance, when someone says card number equals 2, right? What happens, right? Inside of the class, this int class, card number actually has what's called a getter or a get accessor and a setter, a set accessor. So in here, you can do things like if it's not just a simple set or a simple assignment or a simple get, you can do things like say, okay, the get might be simple, just return the number. But if you equals 2 as the value and say, okay, if the value is within there, then assign it. If it's not within there, don't do the assignment, right? So this is a way of enforcing certain things. If it said, for example, you have a card number, you never want it to be the card number to be 13 or 12 or 11 or 0 or 1, right? This way, someone else writing code for you or using your library, your classes, won't accidentally change things in weird ways, right? So it's useful to use properties as variables whenever you want to potentially watch to control how they are saved or how they're accessed, right? Declare a property without defining anything for get or set, and it will work like a basic field, but with additional functionality. Okay, So you can just say get and set, and it'll have that same basic functionality. You can leave out the set accessor to remove that functionality. You can use one or the other. Just have get. And you can also make them private to limit how they can be accessed and assigned. Right, so you can use that within you can make certain strings, certain fields within a class only accessible in certain ways within that class. Right, so this is kind of cool. You could say, okay, other classes can get this value, but they cannot set the value. Right, so you can have read-only fields within your class. We talked about overloading functions within the scope or overloading in general as an object-oriented concept. So sometimes you do have more than one copy of a function or one version of a function that accept different arguments. For example, you might have print message that takes a string or sends nothing. And if it doesn't get a string, it's going to say, you just called print message and got the default. Right? So it's a handy thing to use. Scriptable objects, we talked about those, had a good example of those. Data containers that exist across all scenes. So they're like that, again, sort of a very specific static, they're an object, a class that is defined to be or designed to be static and referred to across things. And have kind of a special way, a special interface between them and the Unity editor so that you can edit them. They inherit from a common scriptable object, rather than mono behavior, because they are, like I said, static. And then it shows up in the asset menu. That's kind of one of the cool interfaces for it. And it's useful for storing information that are, say, certain collections, such as the player health, or things like if you need a collection of commonly used prefabs, for example. Like in my CoinGen game, I created these sort of occupants. I think I called them occupants, or what were they called? The people in the town. And there was a list of prefabs that I then assigned to the scriptable object. And then anywhere inhabitants, I think it was called. So the inhabitants scriptable object I could refer to that whenever I wanted to figure out, okay, what is the list of prefabs, right? So I made a list of available prefabs as a scriptable object I could then refer to, right? Very, very cool things if you want to refer back to that, one of those simple scriptable object. So take a look at these. Consider, would it come in useful to use these in your final project to make your code clearer, your code more readable, you're more reusable, and going forward, if you want to use them in other projects and so on. All right. So that takes us to the end of the kind of tips and tricks and so on, and ways to kind of hopefully make your code more reasonable and readable and so on. Again, this class, this isn't necessarily, hopefully it's not designed to be a replacement for any of the other computer science classes, and certainly not your more advanced computer science classes, but it touches on a lot of common areas and common concepts. So hopefully you'll find these useful if you haven't run across them. I'm curious. I'll put a let's say any of the patterns in other classes yet. I'm curious to know, hopefully you've at least heard, there's a really great book by the Gang of Six programmers, I guess, who created, programming patterns. There's a programming patterns book, and there's a game pattern programming book as well. Both excellent. Common structures within computer science, common algorithms in computer science are going to be useful. And there's always going to be particularly useful ones in games. All right. So I'm going to end that there. That'll cover it for today. I don't think there's a lot of other material that's really necessary for the final project at this point. So I'm going to try to refine, and I'm going to be, here to answer questions about, anyone's questions about, okay, what if I do this in my final project, is that fine. And should I change it this way? I would do that. What I'm generally looking for, of course, is the traditional side-scrolling platformer. It should be bigger than one screen, so there should be some more sophisticated camera motion. The camera should sort of, but not. I mean, it shouldn't be. It should be more sophisticated than a literal parent the camera to the player, right? That's too simple. We want to do something a little bit more intelligent to that, to make sure that as the player moves around, you see the appropriate thing, or there might be triggered camera motion in reaction to someone. So I'm looking for a level of polish in your game in this final project that may not have been in some of the other ones. Some of you have already had some pretty cool camera motion systems, but I'm looking for at least the basic. So I know I have at least one example of that already in my YouTube channel, and I'll probably provide another one of that. And like I said, for the most part, I think we've covered the sort of things that we're going to have in there. If anyone has any suggestions, a particular thing you're looking for, would like to suggest, you can always reach out, send me a instant message or a direct message and say, hey, could you try this? Or would it be appropriate to, if you have something specifically that just you want to see, we can talk about that. And maybe it's, we can elevate it to the whole class if the whole class might find it interesting. Otherwise, we'll continue going forward with that. All right, we've got at least one comment or question. Just a sip of tea here. No, maybe not. Nope. Okay. Well, if you do have anything, reach out to me. Looking forward. If you haven't, I'll just say this. The people who did put more investment into their designs in the game, it really showed when it came to the execution of their games. So I do expect that you're working from sort of more of a design for this particular one, so that we have, I'm looking for something that plays as if it was a level to a game, also. So hopefully it shouldn't just be a tech demo. It should be sort of something that plays like a level of a game. Oh, maybe there is some typing. Okay, I'm going to stop streaming, but I'm going to pay attention to the other typing stuff. Okay. All right. I think I'm still